Perfect, thank you. So hello everyone, and thank you, Jimmy, for organizing these meetups. I'm proud to be here today. My name is Paula Ramos. I'm a computer vision PhD and a senior computer vision machine learning advocate lead at Boxel 51. And today we are going to explore a topic that is both technically fascinating for me and practically critical as well. And I'm talking about anomaly detection in visual data. We will walk through the underlying theory, and as well, we will have like a little dirty hands with some live examples. If you want to access the slides, so you can scan this QR code, download the presentation, and you could have access as well to the hands-on experience. So let me jump here. A little bit about me, a quick intro. So I started my AI journey 20 years ago, back in the pre-tensor core days. Just clever math, slow CPUs, and a lot of caffeine because I love coffee. Since then, I was leading efforts in different companies, Intel, the National Federation of Coffee Growers in Colombia, South America, and also North Carolina State University, applying AI to different areas like agriculture, manufacturing, visual safety, and hardware acceleration. And now I'm focused on helping you, developers, teams across the world, making visual AI real and accessible through our open source platform, FiftyOne. So if you want to keep this conversation, so you can follow me on LinkedIn, also join our community. You can scan the QR code, and also Jimmy has been sharing those links in the chat. Again, download the presentation. You will enjoy that after this. So let's jump on that. What is anomaly detection? I think that we know pretty well what is anomaly detection. Maybe we have some beginners in the audience. Let's start with the definition. Anomaly detection is not just about spotting anomalies. It's about identifying what we didn't expect, what we didn't necessarily train for. In manufacturing, that means detecting defects, rare events, or outliers, each with different root causes and implications. So, for example, here, we can see visually, we have some capsules some capsules are flayless, while others have some scratches, or we can see like a missing text in some of those. Question mark is, can your model pick this up? Can your model localize these defects? And that is where anomaly detection systems shine. So we have multiple methods with anomaly detection. Let's talk about methods beyond Gaussian. Traditional approaches assume the world is Gaussian. The world is symmetrical, clean, predictable, but abnormalities are not Gaussian at all. We will look at techniques like student-teacher networks, memory banks, and contrastive learning. Each has trade-offs in complexity, interpretability, and robustness. So let's jump with one example to one method that I really love. This method, I think that is super stable. Not just for training, also for inference, for running this on different edge devices. So this is a PaDiM process, one powerful method. And PaDiM means Patch Distribution Modeling Framework for Anomaly Detection and Localization. So this model implements the PaDiM algorithm for anomaly detection and localization. PaDiM models the distribution of patch embeddings at each spatial location using multivariate Gaussian distributions. So the model extracts features from multiple layers of pre-trained CNN backbones to capture both semantic and low-level visual information. During the inference, it computes Mahala noise distance between test patch embeddings and their corresponding reference distributions. So I know this maybe is too complex, or let's make it a little bit easier. So PaDiM process uses pre-trained CNNs to extract features, apply dimensionality reduction, and compute Mahala noise distance to identify anomalies. Just think about the model knows what is normal, so the abnormalities stands out. And something that is really mandatory, a big advantage of PaDiM and similar methods is that this is unsupervised. So you don't need label of anomalies to start. You train on normal data and just look for deviations. And the result, these kind of anomaly maps that localize unusual regions like a scratch or missing labels. So let's take a moment to evaluate models, the model performance, coming from these kind of data sets. So as you can see here, the results look really clean, almost no mistakes, strong detections in this confusion matrix, and localization. Really good, right? But here is the catch. The performance may be a little misleading, in the production line. Why? Because this evaluation is done on a data set that was collected under very stable control conditions, same lighting, same environment, consistent defect patterns. In other words, the model looks great, not just because it is powerful for sure, but because the data set is not pushing it hard enough. And this is where many anomaly detection pipelines break when deployed. They haven't been tested under the kind of variability you actually get in production. So question mark is, how do we fix this? How do we build data sets that reflect the real world messiness we care about? And we know that we can use synthetic data, as Matt was showing this today. Let's talk about this approach. We need to talk about data-centric AI. So now we have seen some of the core techniques for anomaly detection. Let's talk about one of the biggest blind spots in most of the academic or prototype level anomaly systems. So the data sets themselves. So often we build and evaluate models using data sets that were collected under identical control conditions. But this is really good, so I don't have any concerns about that. This is really fine for benchmarks. But let's be honest, and this is not how production looks. In the real world, we are talking about maybe manufacturing plant, warehouse, assembly line. The conditions vary. The same object may look different depending on the lighting changes, those camera angles. A lot of things could happen in the production line. So a model that performed perfectly during the offline testing could fail in production. And it is not because the model is bad, it's because the data distribution has shifted. And the training set didn't capture enough of that variability. So this is where data-centric AI becomes essential. Instead of over-optimizing your model architecture, increasing the complexity of the models, we need to be focused on optimizing the data set. Not just for coverage, for robustness and generalization. So, and let's deep dive on those challenges, how we can improve that. So we need to create better data sets instead of trying to increase the size and complexity of our models. So, for example, one approach to improve the models, to improve the data sets is find augmentations that can simulate scenarios such lighting draft, color shifts, blurry images, or even rotations of the expected objects in production. So, but let's be honest on that. So we could have, we have here, this is FiftyOne, this is the platform. We can visualize, all the augmentations that we are creating with these screw data sets. But we need to be honest, it's just the tip of the iceberg. So what is present underneath are the hidden challenges that we have in production. Moving the things from prototyping to production. So let's talk about every single challenge that we have. So we have interclass variability. So even normal samples can look really different. Think about, a slide wear or tear on a machine part, or even labels that printed a little bit off center. So your model may start calling those anomalies, when in reality it's just part of the operational variance. We need to capture that as well. Localization quality. It is not just about detecting that something is off. So we need to pinpoint where the abnormality is. If the model flags a defect but cannot localize it properly, so that is a missed opportunity for quality control or repair systems. Something that is really important is the threshold estimation. Most anomaly detection systems produce a score. That is not a binary decision. But where do you draft the line? This is how we can define that threshold. A poorly set threshold can flood your pipeline with false alarms, or worse, let real issues slip through. So it is really, really serious. So we have also the environmental robustness. A model may work great in the lab, in the test that you are doing, but what happens when you change the light, change the camera angle, introduce maybe dust in the objects? So most models are not ready for those shifts, and that is a real problem in production. And for sure, last but not least, is some anomaly detection models looks great on paper, but until you try to deploy them on edge devices or constrained environments, you need to find the best way to work with those models, because it's not just about accuracy. It's about also efficiency and scalability of those models in production. So while our models may appear ready when evaluated on these kind of conditions, they cannot handle the diversity and unpredictable of the real world. So that is why we need to start thinking beyond the surface. And design our data sets and evaluation strategies with those hidden challenges in mind. So for that reason, synthetic data set is a great option, but we need also to have maybe some real, real data sets. So how do we address those hidden challenges, like intra-class variability, environmental robustness, and localization quality? So one of the answers is we need to create better data sets. So in here, I'm showing you MVTec AD2 dataset visualized inside FiftyOne. You can also take a look of the paper coming from MVTec this year. So let me first explain what MVTec AD2 is. So the dataset that we are using here is one of the most comprehensive benchmarks for unsupervised anomaly detection in industry settings. So it includes high-resolution images across 8 challenging scenarios, from bulk goods like rice and walnuts to reflective metals, textured fabrics, and transparent objects like vials and fruit jelly. So what makes MVTec AD stands out is how it mimics real-world complexity. So objects are occluded, overlapping, or highly variant in appearance. Anomalies may appear everywhere in the image. This is really important, including edges and corners in the image where many models fail. Even uses industry lighting setups like backlight and dark field illumination. That is also common in production, but often that is ignored in datasets. So that makes MVTec AD2 an ideal choice when you want to build and evaluate models that are truly production ready. So in summary, this is one of the few publicly available datasets that actually reflects more realistic production level complexity. So what is great using FiftyOne here is that we can dig into per sample anomalies, compare predictions visually and statistically, and break down label distribution, category label, category balance, and feature behavior. So notice how the dataset also includes good and bad. We have also multiple parts, multiple object types, varying backgrounds, and different anomaly types. This kind of dataset and visibility is what allows us to build robust models, not just accurate ones on paper. So because again, and this is something that I really want to have clear in this talk, it is not enough to detect the obvious. We want to detect the unexpected because we don't know what is going on in production. So let's jump to the next slide. So I just want to keep this slide as a reflection. We have two choices. We can increase the complexity and the computational cost of our models. And we can also keep these bias issues with our models. We need to move to data-centric AI approach where we can reduce those bias and errors. We can be focused on the data set quality, and we can create like a cost-efficient optimization. So, and this, if this is not clear, I invite you to select which path do you want to select. So I will prefer to go to Disneyland than go to the Lord of the Rings land. So let me talk about this. So, and this is really important when we talk about anomaly detection. We need to think about actors in the field. So let's move the theory into practice. How we can move this theory into practice? We need to join forces with leaders in the field. So, and together, MVTec and Anomaly, in Boxel 51, we have been proud to be organizers of the Band 3.0 challenge at CVPR 2025. So this challenge invited the community to push the boundaries of anomaly detection using more diverse and realistic data sets. So why it is important? Because to truly improve how anomaly detection works in the real world, we cannot stay in the academic sandbox. We need to move beyond isolated experiments and single industry use cases. So we need to combine forces here. So, and by collaborating across organizations, we are not just sharing data. So we are sharing expertise. We are also sharing challenges and solutions that span to multiple industries. So we were encouraged to the community to bring the real world scenarios and improve model performance that actually matter in production. So, and it is not, and these logos is not just companies. So we are trying to create an ecosystem that we can solve the same problems from different angles. All of us, we are trying to make anomaly detection truly robust and real world ready. So if you are interested also to be part of the next challenge at CVPR 2026, don't hesitate to connect with me and we can start the conversation now. So let me jump to the next slide where I want to explain you what FiftyOne is. So this is the only open source, fully data-centric visual AI solution. So with FiftyOne, you can curate, analyze, annotate, and debug your data sets. Also, you can evaluate your models and extract the metrics from those, including also find and fix labeling mistakes. So basically, FiftyOne can help you to optimize your pipelines. So, and I think that now it's time to jump in the hands-on experience that I have. I want to show you how FiftyOne is working with MVTec AD2. You can scan this QR code or click MVTec AD2 and you will access my notebook here. You will access this one that you need just to download the MVTec AD2 dataset and run the notebook. Really nice. So I don't want to navigate the code. I want to make that during the getting started workshop where I will explain you how this is working. So basically, FiftyOne is an SDK, but also is a GUI. So, with FiftyOne, we can manage our data set. We can also gain a lot of insights of our data set in different momentums. If we are talking about raw data, annotations, and model predictions, we can bring a lot of insights from our data set and understand better how this is working. So, for example, this one here is a FiftyOne GUI, where basically we have the visualizer of the data set. Here is the whole data set. And here we have all the metadata information. So I can basically here in this menu select labels for categories that I have in this MVTec data set. So CAM, fabric, fruit jelly. So for example, select fruit jelly. And we can see here also a lot of, maybe we can see the category. We can see also the defect. We can also filter the defect if we want to see, just bad data here. Something that is really nice I will clean these filters. I will have the whole data set again. We have a lot of interactive plots. So here, for example, this is a plugin where you can gain insights of your data set and understand the distribution. So for example, here we have the 8 categories that we have. I can select one of those. For example, I can see rise. Clicking the bar, I can visualize just the rise. And I can see here category, defects, and segmentation. So, but it's not just that. I can also see what is the shifting that MVTec create on that. So I have overexposure information. I have regular. I have different shifts in the lighting and underexposure. And also I have here bad and good, but also the folders that I have for training, validation, and test. So remember that we are talking about unsupervised. So for training, we can see just normal information, just good information. And for testing, we can see both bad and good. So, and that is what we have here, bad and good. So, and you can see that we have a balance shifting for those files in the testing data set. So there is multiple ways to explore this with the dashboard. We can also jump to the group of this kind of information, and because we already have a segmentation mask, so that maybe I'm not able to take a look of that easily. So I can click here and identify that I have here a problem with the branding name. So the segmentation mask is showing me where the defect is. So we can cover here with group data sets a lot of information coming from our data sets. I remember a question that was posted in the Q&A about how we can store or bookkeep the timeline with images. If we have, for example, CAD simulations and we have samples in reality, how we can capture this in the timeline. So you can create this kind of group data sets and try to put here not just the original image, but also how this is moving in time. So this is another example. So, and another thing that is also important, we can capture and gain insights from our data sets. So in this case, each dot of these embeddings dashboard, we can see as an image. So basically, each dot is a high dimensional vector with a dimensionality reduction that we are running here. So we have the whole data set, and we can color these dots that basically we have the whole data set there, and we can see this by category and say, hi, I have these categories. I can see the clusters, and I can see, okay, what this cluster means. This is interactive plot as well. I can see this is walnuts, and I can also take a look of another stuff that is really important. We can also calculate issues with my images. So I can see, okay, show me the entropy of my images. I can see a value here with the entropy. And I have the entropy here, for example, is 7.4. So what happened? I can also color this by different insights of my data set. Let's think about entropy. So, and entropy, the number of pixels that we have that increase the complexity of the image. So this is the more complex images, because maybe we have a lot of changes in pixels for sure, Fabric. And this one is the low entropy cluster that are more about like a binary and gray scale with Vial. So this is the demo that I have for you. You can also replicate this by your own. Check time here. I think that I have maybe 5 minutes more, right? Okay, so let me continue with this. So with FiftyOne, you have data to production where we fit. So FiftyOne can handle data management, annotation, and model evaluation. Everything that you have a part of that in the MLOps pipeline, you can integrate with different kind of integrations that we have in FiftyOne. You can run augmentations with integrations. You can run the training process of fine-tuning and also testing and validation using the integrations that we already have with FiftyOne. And you can also monitor your model, maintain the model, and send back information to FiftyOne to check, how this data is coming and keeping the model with the best performance taking into account the dataset quality. So you have two options with FiftyOne. So all that I showed you today is about the open source platform. We have a thing, if you have local data, if you are making individual experimentation, and this is focused in single user, you can use open source and you can scan this QR code, the repository that we have and documentation. We are also, welcome people to create contributions. If you want to create a plugin that is important for you in your manufacturing process, you can create a contribution and make the PR in our GitHub repo. The enterprise is for different kind of users. So if you have billions of samples in the cloud, different providers, you need to have like a streamless connection with the MLOps orchestration, or you have multiple user collaboration, you need to use the enterprise. So in that case, if you are interested to do that, you can book a demo or try FiftyOne in your browser. So you can take a picture of that, scan the QR code if you already have the slides, so you can click over there. So we are supporting multiple kind of computer vision tasks, classification, segmentation, instance segmentation, polygons, polylines, and also multiple formats. So we are supporting 3D, point clouds, videos, images. If you have metadata, you can also include that metadata. And basically what we are doing is we are creating an unstructured data set where you have a lot of information coming from different sources, and you can centralize all the information in one single platform. So what we have, so imagine that FiftyOne is a client server architecture where we have the SDK in the back end and the GUI in the front end. So you can, all the things that we are doing with the SDK, you can also do that with the GUI. With FiftyOne, you can also manage the dataset structure. This dataset structure looks like a normal database where you have a table, we have samples and fields. With metadata, we can include whatever you have in mind. We have no limitations. So you can include embeddings as metadata with different kind of indexes that you can gain a lot of insights from your data set, like a similarity, duplicity, uniqueness. You can also have the feature vectors and use the feature vectors for anomaly detection as well. You could have also annotations, labeled model predictions, and finally, you can manage everything and centralize all the information in one single platform. If you want to train a model with Anomalib, I don't know if you are familiar with Anomalib, so you can try this notebook. So Anomalib basically is a library that contains the state of the art of the anomaly detection models. So basically, it's straightforward, and you can work with Anomaly in FiftyOne. So if you want to train your model, you have your own data set, you can use Anomaly as well. So I invite you to scan this QR code and take a look at that and see how this could fix your problems. So just wrapping up, so we have a unified platform with a lot of benefits. So time efficient, cost reduction, accuracy improvement, and answer enhancement. This is really important with the visual AI platform that I'm showing you today. So, and we are super happy to be the lead maintainers of this open source project at Boxel FiftyOne. We are making visual AI a reality, and we are always welcome, people to create contributions to our platform. What is next for you? I invite you to pip install FiftyOne. You don't need to subscribe to anything, just pip install FiftyOne. Take a look of the tutorials, try those tutorials, check the QR codes of this presentation, join our community. If you have any questions, we can solve those problems there, and attend our events. As Jimmy was mentioning at the beginning of the meetup, we have 40 more events this year, and you can stay tuned. So tomorrow and Friday, we will have day 2 and day 3 for this amazing visual AI in manufacturing. And also September 30, we have the workshop where we are talking about beyond defect detection. We will talk about worker safety and video analytics.